Please bear with me, allow me to continue from where I had left off yesterday. I had to go back and rework a little on this model which I was trying to show you. So please have a look at the monitor. So if you remember, I started with something with this a little bit of these keys and this thing saying, can I make sheet metal out of it? Yes and no also. The thing is, in general, sheet metal behaves slightly different from the way the other things behave. So what I will do at this point is see if I can now work back and see whether the concept sketches and all these things can be improved upon. If you observe this a little carefully, one of the first things you will notice is I have tried, as I have told you earlier, I have tried to start a layout in a plan view and trying to build on various things which I have had outside, including all these what do you call various types of pictures and hardware items and so on. Today most likely I will be able to show you how these things will go into an enclosure. You have two PCBs, rather three PCBs here, one has a camera and then this is some TI board and this is some other standard thing. How these things will eventually be put into a small enclosure. This what is the focus of the whole thing which I wanted to do yesterday. So today allow me to get back again to this concept of a simple enclosure which I can put it into a PCB can be built around it. So just let me say I got carried away a little and then I will now start fresh here at this point. I will call this a top portion and then I will make one more thing which I will call a bottom portion. Okay. I go back to the concept drawing, go to the top because it is a little easier for me. I have started with a nice simple clean rectangle and I continue to work in the concept layer. So in this rectangle the idea is normally we are supposed to put a printed circuit board or various details underneath and then I am not able to work on the fly and make these things demonstrable easily for you. So instead what I will do is I will now work with a imaginary what do you call constraint. This is the top and then this let me say it is a front view. This is where I had started. So I start with a this is how my side view is likely to look. Because of various practical considerations, allow me to play around a little with these things and see See, I have improved upon the thing which I had started yesterday. So, my side view is likely to look like this, and then I will try to build a small what do you call sheet metal enclosure to seat these things, and then see if I can incorporate those devices which I have kept there. And then yesterday I was trying to tell you about, in case the dimension does not fit, how to increase or decrease those things. And then one more I would like to also point out that this is only one of the what you call simpler softwares which we can download off the net and then use it in a trial version. I think 25 saves a version of it. You see this, I have a profile of this, whatever my project is going to look like. This is where I tried to tell you yesterday, saying if I now want to make a sheet metal enclosure, I should develop starting from this long bit of a profile. 2 or 3 things you will notice here. Now, if I try to dimension these things, kindly what do you call, just bear with me until things, okay. Yes, in this it has come to not so what do you call integral numbers. Thing being, 2 things are here. If you are working with sheet metal, one is dimensions have to be accurate, then the concept of the bending allowance comes there. Now, can you incorporate the bending allowance here and make the final drawings, has been the thing which I wanted to insist on yesterday. So, if I go to the other view here, top, you have seen this. What we want is that outline which I have shown you, which I could successfully put it on this and then make into a surface, which is easy. If you ask me, probably it is much easier than the other things. Now, when I go back, I just wanted to show you how to work with this. So, 2 very important or rather 2 points to note are this dimension should be as per the requirements, including we have a PCB layout here and how those things work on the PCB layout and all that. Right now, in view of the time and all that, let me go a little fast. And second thing is, whenever we are working with sheet metal, we need to add the bending allowance, and bending allowance again depends on 2 simple factors. One of them is the thickness of the material and the way the material follows the fabrication. The fabrication steps followed to make the bending, and this is a little theoretical, a little practical, and then they are all, it has been tried, theory has been applied, and then it has been updated and all that. So, test specimen we make and all that. And something which is quite important to notice, these angles are again, you have seen this deliberately. Oh, it is in a different mode. So, I need to break it and so the internal angle is not 90, it is in fact a very odd number, some 102 point something. Similarly here, internal angle is something else, internal angle is something else again, and not a nice convenient integers. Which we have tried to show you in the earlier lectures and done in the workshop itself. Now this is again directly proportional to the angle. So for 90-degree normally, depending on our materials and all, we have some 0.56 millimeters depending on the clamping and the fingers radius and all that. So if something, the angle is what do you call depending on how do you do the bending is less than 90, let us say the 147 in this case is the amount of bending required, that is compared to the straight line, is less than 90. In this case now, the bending elements you need to add is less. So in a flat sheet, logically there is no bending element, so it is then when you come to 90, that is the one it is. As you keep increasing the bend, that outer angle keeps increasing all the way up to 180, slowly you will notice that the material properties and the way they work change a little. So it's as I said, you need to try it. So right now this focus is not on this, it is more about how to make so I will just delete all these dimensions and start fresh. Okay, how to make the top and bottom covers and the actual formation using this and so on. So what I will do is, in fact I will remove this top thing only. So the only useful thing I have, this is side view. So what I need to do at this point is try to join all of them together so that I have a nice object here, and then just it's a matter of because I am working on the fly, see here. So I have my device which looks a little like that calculator and all those things. So now what I will do is, I need to decide on how the whole formation is going to be. I said top cover is going to come here, then I have a bottom chassis, and then I see what best I can do with it. So I will go a little faster here. Oh, okay, looks a little like what I wanted. So the top looks fine, and then it is nothing but except that it's not a, it's just a collection of lines. There are points in space and then whole things have to be joined together. Now I will see what I can what you call do with it. You see here, this one was, if you remember, no, I had started with a what is called a polyline. So I have something here which will make see here, I have created two surfaces which represent the left and right faces of the object, and then one more surface also I will try to create here. See here, I have the bottom view portion of it. So for the present, what I will do is, I take all these three items and then I will go and change the properties here. Instead of being in the construction line, I will make them into the bottom plate. So they all come in the bottom. If I switch off the bottom, they are not visible anymore. You have seen this on and off. Now I will try to do the same thing with the top. I will then to continue making a surface. This is a very important surface for me, so I start with that. Similarly, this is another surface, I start with these two things. Now, when I join these edges, sometimes depending on the type of program, the precision and the platform on which it works, there may be small errors. These errors, they are no problem in a very simple geometric object like this, but you have a complicated shape, and then when you are trying to print it in 3D, we end up with unstitched or unwelded surfaces. These unstitched unwelded surfaces will cause problems. So, to make use of, to avoid it, generally this I have found out that it is much better with already start with things which are known here. If you see, I have a surface edge plus I have the curve also. So, I will stick with the surface edge, and then here also I will stick with the other surface edge. Now, you see here, this is likely to be a little more true compared to the what do you call something which I have started with the lines. To continue with it, what I will do is I will go back to the top, and then if you remember all these, if you see here, they are still in the construction what do you call area. So, I will change them also to the top. So, now this concept or concept lines I can hide. So, nothing is lost here. I have my essential things which are here. Now, this last two, you see here, this and this I need to attach together. In the beginning, for the case of convenience, I have shown you saying I have created this using the construction lines. Here, now go back on the what do you call, in just what I have tried to say a little, I will now delete all these things and see if I use the edges of things which are already created. There is a small thing, will avoid the error. So, what I will do is, I will now try to create the surface using edge curves. I will try to use edge of this and edge of this. I have it. Similarly, I have edge of this, I have edge of this, I have it this and this, yes, this, see, I have got most of them covered. See this. Now, since I have been playing with the thing as before, now when I switch off the bottom, I have this beautiful top which is sitting peacefully. Similarly, I can switch off the other one, I have this bottom. If you are working with sheet metal, and then if you are a little what do you call perceptive and careful, you probably need not do the whole exercise which I am about to do, but anyway let me see how I can carry it through. I now work with the top. Here comes the interesting thing, saying for us to look at something which is coming from the top, the side obviously has to be like this, and then the top has to sit on it, so that on the top we do not see anything. Now, I need to somehow make sure that this overlaps here by the thickness. This is where the big decision we need to make. If you want to protect the or optimize the space inside, probably it is much better you go and build the surface to the outside. You try your best and see what else we can do with it. Alternatively, if you want to make sure that the external size of this should be, let us say it is decided saying it should be a coat pocket or something, and then external size is restricted. then you build the surfaces toward the inside. It is easy to say, but slightly more how to tell difficult to implement. So, let me try with bottom plate once. You see here I have this, depending on the type of what do you say, the facilities that are available and so on. So, I take this top bottom portion and then I see I have been able to make it into 1 mm thick something here, same thing here. And here again. You see, I have what looks very much like a 3D solid. Just ignore the corners for a little while. It is maybe a mistake which I have done, or maybe it is something and so on. Right now, no, just allow me to ignore the corners. I have a beautiful, what I say, nice object here. This is probably the reason, no, very rarely you will have those things sloping at the 45, I am sorry, at an angle when another surface has to meet. So, generally, no, even if it is sloping in the last, they will try to bend it a little and make them like this. Once you make it, there is a good reasonable chance of things meeting here. So, you see here we have a little problem because this top portion, it does not join easily. Maybe it makes sense if I try to extrude it in the other direction. Shall we have a go at it? Now, I will see whether I can make a solid by extruding it down. Saved, isn't it? It is a beauty. Now, this is where we have small advantage. Now, if you see the top cover, it stopped angled like this. So, you need to make a small projection so that it goes down here. This is where the genuine solid modeling helps and proper solid things help. Now, what I will do is, I will just see, I will use the standard union and then see whether all these things join together. Very good, everything has joined together. And, oh no, it did not join at all. Boolean union failed like that. I do not know why the Boolean union failed. I will try one more time. I will see if all these three things will be able to. I had selected the wrong objects. There were that construction surfaces which were sitting there. This is the reason why I said we must have a concept or construction what do you call layer in which we work. Now, you see very conveniently and very nicely, I have an object here, and then if I try to use the rendered thing, it even looks nice. Can you see? Back. And then I see whether under this render properties, I can reduce the background that color. Oh. Oh, I am not able to. I think I will have to work it outside, otherwise we end up with yeah. Viewport color was background little this thing. I will now see. No, I will leave it. Excuse me for the little. I shouldn't be playing around, but I have done it. I will just try to see what best I will do it. I will now go out of this and come to the standard wireframe model. Now you see here, slowly we will see what best I can build up these things. In reality, sheet metal, there is nothing like sharp 90-degree bend. If you are to make it, chance are it will crack, or there will be a small definite bend. Only in a very peculiar condition called the fine blanking, you can come as close as you can. Elsewhere in mechanical engineering, if you want to avoid that corner, in fact go out and make a circular opening and then try to push it inside and all that, we will leave it. And now I will see about the what you call very interesting thing called filleting the corners. And then by default it shows 1 mm radius, and then I said we are very much familiar with this 0.5. So you see here, nicely something has been built up. See this here, similarly on the outside. See, nice cute thing has been built up here. Now, if I try to go to the inside and try to do this, see, try to do as best as within the what you call, I will say, ignorance of my settings and all that, just try to do as best as possible. But you will notice still there is something hanging around here which is not what I wanted. There is a small problem with the radius in the corner. Have you seen this? So, we need to work on this to make sure that in the end we do not get any surprises relating to this part. So, what I will do is I will try to undo, go back to the very beginning of okay. This is probably where I had started. In this, recollect what we did and why we came here. Now I will say whether I can marginally improve on these things which I started, which was actually a small problem. I shouldn't have done this without considering that the top, when it comes down, better be straight. So I will try to now work on this, try to delete all these unwanted things and see in here, this is where I had started. Now I will try to go back and say, if I try to do something to make sure that the bottom portion needs to be a little straight. So what I will do is I will do the very obvious and simple thing, try to what do you call, there is a command called make it back into individual entities, then move it a little, maybe about that much, and then now try to add a line. If you see this will partly take care of the problem which we had faced there. And why I came back here is, we will come down to the next position saying, while the bottom was convenient to build and we wanted the top to be kept on top of it. So, I will say there are several ways how this can be done. One of the easiest ways will be obviously make this whole thing into a single entity called a polyline. I will join all of them, this has become a polyline. And now try to offset it to the thickness what we wanted, which is typically, I will make it 2 mm. Oh, I pressed the wrong key. It shows that, see here, now I need to take that important decision at that point, saying which part of it will be the top cover, which part will be the bottom cover, and then where do I stop. So, I now try to see, this is obviously not very useful for me, this bottom portion is not useful. So, I will sort of chuck it by removing it. Okay. Now, if I look a little from the side, see, this is how most likely that object which I was talking about would look like. See here, interesting for me. So, all I need to do is, if I want to make the top cover, I just call this stuff, this part of it is the top cover as I was telling you earlier, and then I now try to transfer all this to the top, and this will remain as the now I switch it off, this is the bottom, and I have the profile, and then elsewhere now I have shown you how to build that small thickness and so on. And then added to that, here you see here I have a nice straight portion here. This straight portion will help me build that radius properly in the bottom. Well, I won't call it a trial and error, I call it experience. Take a little interest in it, and then I have told you before now, you have to plan, play around, and then finally I'm sorry, you have to start, plan, you have to play around a lot, and finally in the end the last execution will be that you make these drawings which work a lot. So, again coming back to the old approach which comes first, you need to be a little familiar with the operations that they carry out in the fabrication shop, and then try to see the type of representation they would like, so that you make these drawings. So, that earlier that over the wall or way of saying there is a standard way of making something and then eventually it gets made is disturbed now. So, coming back, I will now go a little faster. This again I will convert it into a, what do you call, a whole object like this, and then try to make a solid out of this. See this, I have a beautiful solid here. I still have the curve there. I copy the curve so that it looks a little like what I wanted. One more time I use this curve to make a solid. See here, I have Using that features which I built there, I have tried to make it now. I need to complete the bottom part of it. So, I use two of the features which I have here. I have a feature here, a surface edge, see, bottom plate has been attached to this. Now, I will see if I can extrude it up again and see whether I am slightly better off. Definitely I have something here, and then I boolean the whole thing, that is make it into a single object. Hey, why did it fail? It has finally become a single object. In this, now I see, depending on the various thicknesses and all that, I have intentionally chosen a 1 mm thick sheet. Generally it will be thinner. The top one was 2 mm, but this is only 1 mm, to see how well we can do it. Now I will see whether I can do the solid, the filleting the edge. I have a 0.5 fillet there. I tried to do, still I have a little problem there, maybe see there, I have this. Now I will see what to do with the external surface. I add that 1.5 mm thick. Oh, sorry, I am not able to make out what could be the problem. I will now try maybe a 1 mm filleted edge. No, still fails. I think probably I will have to work out better on this and get back. So, please bear with me, and then I will see what best I can do. But meanwhile, let me go back and show you next what you call level of our working is going to talk about how to do the organic objects using several shell commands and so on. So, we have a top cover here, and then as I said, we played around with this and all that. It is very much possible for us to create these objects without too much of a problem, and then attach all the various devices and all which we have inside. I have a little problem with trying to show you with the what you call resources I have on my desktop. It seems to work well. Here I am not able to show you how well it is, and the issue being that it is possible for us to work with the starting point, that is a what you call, we have a construction or concept lines, and then try to create a solid using various digital sculpting techniques, and then try to make parts out of it. The beauty is, now if you are to take a part like this, you can very easily create if you were to mount a display or a printed circuit board or anything, you can now attach small bosses which nicely go and sit on top of this, which have that screw, which if you remember I took it from here. You remember the small screw which I got from how? So, we see here that things which have been created elsewhere, I can export them, import them here, and only once in my what you call professional career probably I need to make these things. Oh, I think I need to introduce them later on. Yeah, no, I couldn't get it here. It is very easy for us to actually get them online. So, this is like when you make the fastener, obviously the fastener also requires the other part of it. It's usually 3 or 4 of them. One of them is the device usually which we loosely say screw, and screws also so many variants are there. One of them is pitch and all that, another is the type of head we want. So, if you want the head to be flush and all that, there is some detail about it, saying it could be conical, or in cases like this we try to generally make them such that you use a cheese head screw, because conical screws have some issues about alignment and so on. And then for that we need called a counter bore and all that. All the detail if you carry, you can always carry it and put it in this and then complete your job in a very simple and convenient way, and then this can eventually be passed on to rapid prototyping condition. I don't know if it looks obvious. You know what it could be? This actually was made as a optical or something made for an ophthalmology thing. So, if I hide this small hood, you will notice that you would have seen this. This is a chin rest. Here you have a chin rest, and then here you have a what you call a device to see that your eye is in the plane in which the sensor can focus it. So, this whole thing is a little mechanical and a little electronic about it. And part of this, for example, this chin rests and all have been approved from various safety standards and all that are available on in the shops. It is only for us to make sure that fit all the other things. This is made with a special material. It's a type of a foam core stuff. You see here the core of it here is this. This whole thing was conceived, built, and this of course the prototype. The advanced version of it is in production. See here, I have a lens here, you can see there is a lens here, and then there is something else here, and for convenience they have shown it here. Actually this will be a little lower and that whole thing will be higher, so that it will be eye height, and then you have a left and right motion. And typically these things, there is a combination of, there is alignment and mechanical, there is a combination of optical devices inside, and there are sensors, and there is something which stores, and in this case probably it transmits retina pictures directly to a remote doctor. It does not have any visible wires or anything. So part of it is in production. I thought you will probably appreciate that all these things invariably depend on remember this which I was trying to show you earlier, the 3-pin regulator, typically your 7805 or 7905 or 7906, and these are all some, I will say some components, loosely I will use the word components. Why I thought I will show you here is, you need to build up a library of these devices. And now we have this, let us say we need to put this on a heat sink. For convenience it is shown flat. But a real heat sink will probably have them like this. Now 2 or 3 things you will notice. One of them is, as I have told you earlier, certain hardware and certain things which are more related to the packaging have to be fixed up front. So one of them is the heat dissipators. You will end up with this if you put them somewhere in the middle of the printed circuit board. You want to push them to one corner, we end up with a very peculiar issue. Instead, from the breadboard which I have showed you, you have a display, you have this, and you have also these series pass, often heat generating elements. Not all of the things have become very small and all. The reality is still there is power being dissipated, there is what do you call, you need to do something about it. I will just see what best I can show you with this. But then you see at the back, this whole thing has been constructed using the outline that has been given in the catalog. So I will just keep this alone on, remove all the other things. See, see, I have 4 of these devices, do not ask me why they are. Now it's for me to pass on this information to the what you call designer, or again to avoid that word pass on because it looks like over the wall, work with the electronic design people to see how best we can make a what you call heat sink and so on. So if I now go to this plan view here, very easy for me to make see here, this is intentional. See, I have something which is repetitive. So it's possible for me now to split this object see this, I have got one of those fins separately. Now it is also possible for me, if out of convenience sake, I will just copy and paste them. You see here, part of my heat sink is slowly getting ready. This is where CAD business helps. If I have some idea how I would like to make these what you call various hardware, now you see all I need to do is see if I can, this looks a little like a symmetrical object. See in this, I have a nice device which is a heat spreader. So I will now complete this thing with so here what looks like a cute heat sink is ready. There is a small error there, but right now I will ignore it. So because of this small joining, because I have put the mirroring, now the thing is, this whole thing now it's very easy for me to seen this. Now I have got a relatively nice acute object. It slightly, the symmetry has been lost, but kindly, I have could retain the symmetry. Now the moment I have this, it's very easy for me to go ahead and another view in which I am I have a something here which I am proud of it. Without too much of ado, I could demonstrate for you. Now the other thing only comes is mounting hardware and all has not been shown yet. So it's very easy for me. Now if I go back to the original this thing, some of them are only mounted directly by a clip. Some of them have an opening and you need to assemble it. I have seen even some occasions where it has been assembled with a pop rivet. And now I have this a beautiful heat sink assembly, and then very easy for me to now construct an enclosure or something, and then trying to see how I can make an opening. In this case, it's very easy for me. I need to make one more block, do a 3D Boolean operation on a solid, remove some material and then push it on top of it. Once I do it, I have the mechanical parts of it is ready. One of them I have a heat bridge, then I have this heat spreader. Outside we can do whatever we want with it. Occasionally they are also mounted inside, and in case you need to have forced air cooling and all that, all the hardware is available. Now at this point, allow me to sort of come to a simple conclusion, saying the conclusion is you must do it yourself. Unless you try it, as you said, all this, I have a slightly bigger machine in which I am able to do a little faster. On this small laptop here, I am not able to, it's not able to handle these things. Otherwise, if you build this large set of things, for example, if you see here the small series pass regulator, or it could be any of those things, they are all standard packages for which detail is available. Secondly, related to that, I have made that small fins and all at the back. These are almost generic, and you can build a library of these things. So all known heat sinks and all, you can make a library about it. And if you want any modification on that, so if I show you, I'll see if I can show you here, do we really need something sticking out here like this? Or would you need something little extra here? Now it is, and then how do I mount these things? Supposing I have a heat sink, how do I go about mounting this heat sink? You have seen here, it looks a little monotonous and so on. Very easy. All I have to make is I have to make 4 openings here so that it is can be mounted on a on an enclosure. And if I want to mount those devices here, I have to make small openings. I have to now make a pitch such that that opening exactly comes here. So one of the simple ways is to measure this. If I measure this, you see that typically a 1 mm opening. So if I have some screw which typically has about those proportions. So if I take an M3 screw typically, if you take the pitch and all those things, you need to drill, I think, a 2.5 millimeter hole. So it's possible for me to make an opening here, a little bit of the tapping touches this, and then I can make a screw. and then on this point here, depending on if the screw were to be bigger, and if I want it here, I can probably make a opening here. I'll just once again on the fly, I'll try to see what best I can make here. You see here, I have this small, which in this case now maybe I should call it a tool, by which I can make the necessary openings on this here. There is no rule saying they need to be symmetric or asymmetric. All I need to do is, if I want them symmetric, and then depending on where I want them, I start with something here, and then I try to mirror this object. See here, I ended up with two of these things. See, I have place for 4 of these fastening devices. Part of it is, for some reason I can explain to later, I have openings here in which the devices need to be mounted, or in this case if you are talking about those transistor like devices, maybe I will concentrate on that. I will remove this. I will go here, I copy more and more of them. Logically, I should have aligned them with the transistors there at the back. So, I go about doing the Boolean difference, select this first set and select each of these, and you see, I hope it will work miraculously the way. Oh no, bad luck. For some reason the Boolean, I think my sequence of operations are wrong. If I do it, it is possible for me to now make this whole thing with all the openings and all in that place. But this is actually part of solid modeling, and then I need to do it in a different way. I will try to work on it. I do not know why it refuses to. Yeah, I got it. It has ended up with a peculiar opening, which has probably caused the problem. See here, that is the problem. So, the thing is, if you now try to extend this and so on, that was not a properly completed solid, which created the problem here. I will see very quickly, so that I will see if this behaves slightly better with me this time. Hey, my what do you call apologies. I think it is not able to calculate the apologies. I will leave it, I will come back and work with it. So, I will stop here. I just wanted to show you that starting from the outside the concept and the space, and then going to the inside, how we can get back to the proper thing, and eventually you will have products which have all the mechanical hardware related to, if you remember, the basic displays, the connectors and so on, and then also some things related to the heat dissipating components and so on. This is a limitation of this package and the machine what we have here. It is easy for us to make these things. So, next time when we meet next, I will try to make it, but the focus being that you must have a plan in mind how you want to proceed with it, and then preferably all the dimensions, everything have to be marked, and you should have the things either written down, or in case you are more familiar with these packages, you can have these things here, and then you will have lot of peace of mind. That is all I can say. I think I will stop here. So, thank you until we come back here. Thank you.